up and help out. So Keith contacted me a few weeks ago, said there was a scheduling issue and the November program is open and could I step in and give this talk? And of course I said I'd be happy to. So here we are. I'm going to talk about the focus here is a code practice oscillator project, but that's kind of the vehicle to guide the discussion. And it's kind of my journey as a know-nothing. I'm a mechanical engineer, so I know nothing about electronics except what I've learned. What Zach taught me. Where's Zach? Zach taught me in the extra class. Thank you for that, Zach. And it was a ton of fun. So starting a year or so ago, Dave Schmidt, AI6VX, that I think many of you know, gave a talk to the K6 MEP group in Ventura about how to make your own printed circuit boards. And that kind of perked my ears up. I'd heard, if anybody listened to the Ham Radio Workbench podcast, one of my favorites, I highly recommend it. They talk about sending stuff off and getting pre-printed circuit boards made. And that is kind of a culture shock. When I was a kid, I helped my dad make some printed circuit boards. I don't know if anybody's done that in the dark old days where you had a copper clad board and you manually put the etch resist in, and then you put it in the bag when mom's not home and etch it out, right, and put it all together, manually drill the holes and find out, shucks, I got this trace wrong, and you grind it. Well, that was no way to run an airline. So when I found there's a new, better way that's easy and quick to get pro quality boards, I was all over it. Martin has this wonderful slow code net on Mondays and the Morse group, and I was interested in joining that. I needed a code practice oscillator to kind of play in that regime. And that just seemed like a great, simple project where I could kind of go through all these steps. I want to emphasize here, this is just my journey. I want everybody to walk out of here thinking that they could do all of this stuff. You may be reading QST or a blog somewhere and there's a schematic and you say, God, that'd be neat. Well, you can do it. If I can do it, and I'm going to show you here how easy it is, you guys can do it too. And there is an amazing amount of top-notch help online for a lot of this, whether it's YouTubes or blogs or other tutorials, university stuff. It is, with all the crazy stuff on the internet, this is like the shining beacon of goodness. So the message here is, if you see something, just do it. So, okay, so I want a code practice oscillator. And if you've been to one of Martin's meetings, people come in and sit in this room and kind of do little simulated QSOs. So I wanted something I could bring in and do that. Vibraplex has this one that they sell on DX Engineering, and I'm sure it works great, but you got all these kind of things laying around, and I wanted something a little better. eBay has a couple of options of various degrees of sophistication. I saw this is an MFJ unit. I thought, God, that'd be perfect. It's all one piece, it's all hooked together. You don't have dongles everywhere, and it'd be easy to transport. But I like to make stuff, and I was looking for an excuse to go through all this printed circuit board stuff. But I had a straight key, and this one's kind of an entry-level thing with kind of sheet metal trunnions and stuff. So I thought, you know what? Maybe this is a good opportunity to try all the stuff that Dave's been talking about. So at the top level, these are kind of the 10,000-foot view. I needed to find a basic circuit design. I went through, and thanks to stole it off the internet, one of the many advantages, went through a kind of a breadboarding development process. And then we get into the software where you define it electrically in the KiCad software. Then you define it mechanically. A little more magic, you send it off to China, and a little blue box shows up in your mailbox that's got these wonderful, this is pro quality stuff. Multiple layers, nice silk screen, the solder mask. You pre-drill the holes if you tell it to. And it was incredibly cheap, as you'll see, incredibly fast. Then all I had to do was solder a few components and here's the final product. Again, this thing sits on the battery, sits back there. That's my key. In my haste to get out the door today, I left it on the kitchen counter. I don't know, I walked past it. I really wanted to shuffle it down here so you could see it, but I'm thrilled with the result, and I had a ton of fun making it. So first step, went to the internet and searched around. There's a number of alternatives. I quickly found this circuit is based on the NE555 chip, which I didn't know a whole lot about. One of the neat things about a project like this is you learn a ton of stuff about things you never would have thought about. This chip is an amazing, to me, elegant in its simplicity and amazing in the flexibility and the way it can be applied. I've got a link. I think Andy will eventually put these up on the website. I have a link to the down here if you want to read more about it. It's just really, somebody was really thinking, and it was neat to play around with that. As you can see, there's just a handful of parts, quick bill of material over there. And I said, oh yeah, this will be great. So bought one of these little mechanical little perf board, temporary breadboard jobbers where you stick stuff in the holes, breadboard it all up, and by miracle of miracles, it actually worked. It worked pretty well. It's got one knob where you can adjust the volume, another knob to adjust the tone. One maybe shortcoming of the simple design here is it doesn't have a power amplifier in it, so the volume is just what you get out of the 555 chip. And maybe it could be louder, but you know, it's loud enough, gets the job done. And playing around with it, I noticed that a couple of times if I forgot to turn it, it's got a power switch, but if you forget to turn it off, it drains the 9-volt pretty quick. And after doing that a couple of times, I said, okay, I need some sort of light to remind me. So my great, and for a mechanical engineer, now remember, my great addition to this is a blue LED and a resistor to make it work. But it was, I had a ball doing it. And I think that's the essence here. And you can go nuts with all kinds of things. So if you see that project in QST and you think, hey, I want to do it, but you know, I wish it had a different connector. Well, you can do it your own way if you do it this way. So that's part of the fun. So that was my great contribution. Now I've got a circuit that I've developed to the point where I'm ready to go forward. I know it works. It'll do the job. Now I just got to tell the software how to translate that into a printed circuit board. So it's really pretty straightforward. Again, the software is free. It is really top-notch software, very highly developed, very smooth, not too many rough edges like a lot of freeware used to have anyway. And I download it, fire it up, and there's this blank screen staring at me. Oh, what the heck do I do with that? What did Dave do? I'm looking around. Well, there's a ton of good tutorials and YouTube showing you how to get through those various steps. So a little bit of looking at those, and I didn't even have to read the fine print, just looked at the pictures. And you go in and you pull out a resistor from a library and diodes and speakers and pull all that stuff up. Click on the various spots to hook it up electrically. And within a matter of, it took me about an evening, I think, to start from a blank screen to a fully developed schematic that was ready to go forward to, and it was a lot of fun. Like I say, I never would have gotten there except for all the help that's available online. A quick Google search, you can answer any question. It really makes it really pretty straightforward. So now I've got a circuit that I've developed. I've defined it now for the software electrically. Now I got to tell it about the mechanical part of things. That's the part that I really had very little exposure to previously. So if you think about it, you got to tell the software everything that has to go into that printed circuit board. And you start with the footprint for each and every little component. And it was a little tedious. And this was one of the harder things for me to get through. Took me a couple evenings, and again, with help from the internet, I was able to do it. KiCad has a ton of these little footprint files built in free libraries. And that's where I got these. In a little while, I'll talk about where you buy your parts can have an impact on this step. If you buy from DigiKey or one of the larger, more traditional parts houses, they will provide, you can easily download the footprint file for that specific part. That will save you some messing around with going through the libraries. But this, but you got to pay maybe a little bit more, or maybe not, depending on how you want to look at it. We'll talk more about that later. But this took a couple evenings. And you have to kind of go through part by part. By the time I was, got towards the end of it, I was kind of learning the ropes pretty well. But at the end of it, for each of these, you've got to tell them how many pads are there, how big are they, mechanically, where are they, what silk screen kind of stuff do you want in it? And you go through that, again, component by component. And again, a couple evenings, I was done with that. So the next step, so I've defined it electrically. The software knows which leads from which pins are supposed to connect to what pins on the other part, and so on and so forth. I've defined the mechanical footprint for each and every one of these individual parts. You push a button and it splats them all out onto the page, and then it's up to you to arrange them the way you want. At first I was a little disappointed. I thought maybe it would help me with that, but it turns out to really be a good thing. And one of the fun parts about doing this yourself, as opposed to buying somebody else's, is you can sit there and I could say, well, I want to be able to, this is going to be sitting up vertically behind the key. I want to be able to adjust the volume and the pitch pots easily. So I want them on top. And I want to be able to turn it on. So the switch needs to be on top. And I want to have this LED telling me when it's on top. And then the other stuff you can just kind of put wherever you want. And then you need to make sure that you've got, in my case, I knew I was going to kind of screw it into a small piece of wood. Need to have enough margin for that, those kinds of things. And it's a little tedious, but it was kind of fun too when you get through it. After you get the parts where you want the components, then you've got to noogie all the little traces around, because obviously if they're, this is a 2-layer board, you can have stuff on the front or the back, but obviously they can't have them on top of each other, or electrically it ain't going to work. So you can see some of these kind of go around Robin Hood's barn. This pin on this capacitor needs to hook up to this pin on the volume pot. So it kind of goes way around here and dodges in around, but sooner or later you get it, and you can play around with that. Some of them you can put them onto the back of the board. You can go halfway on one and then through the board and then back. So it's kind of a big puzzle. And it took a couple evenings to get it right. But it turned out to be a lot of fun, and I really liked the idea that I could put the stuff where I wanted it, not where, maybe somebody else did. I'm sure we've all used stuff and you say, why does that chucklehead put the switch where I can't reach it, or I got to reach behind it, or whatever. So you have control over that and you really get what you want. Now, this is a 2-layer board. This was kind of challenging geometrically for me. KiCad will handle up to 14 layers. I think James, maybe some others here that do this stuff professionally can do that. My hat's off to you. And on top of that, I'm colorblind, and I don't think I could see 14 different colors, let alone manipulate in my head 14 different layers. But again, now I've gone through and I've defined it electrically. I've defined each component mechanically. I've arranged those on the board mechanically. I've got the traces set up where hopefully they won't intersect or give me any trouble, I'm done. Okay, so now I've got everything designed inside the computer. How do I get a physical board out of this? Well, at Dave's suggestion, this is kind of the final product. You can, in the CAD program, you can look at it, the front, the back, twist out or whatever. You can populate this, you know what it's going to look like with the components, or you can take them out. Again, you have a lot of control over what it's going to look like. Well, so you got to get it made. This is an outfit in China that Dave Schmidt recommended. And I'm still amazed at how cheap it is. You take the output from the CAD program. You know, you go out, it took me about 5 minutes. You go to the website, you create an ID. It says you want to do a project. Yes. Give me the files. You show it where the files are. It sucks them in. And it comes back and it says, in this case, 5 boards, which I think is the minimum quantity. They're small, they're maybe 3 by 3. Was going to be a whopping $21.64, but there's a first time order $10 discount. So 5 of these things, and I got the expedited shipping was $12. $12, and it showed up in my mailbox in less than a week.
Wow.
I think you can save money on the non-expedited shipping is half of that, or maybe even free. So if you're a little patient, you can save even more. But this was just phenomenal. So okay, you push the button, off you go. Give them a credit card, $12. And a few days later, the blue box shows up, and the thing is just whoops, pushed the wrong one. Is just absolutely, it blew me away, the quality. You can put your own titles and silk screening on. It looks just like something that you'd get out of a Yaesu radio or something. $12, $22 if you're not a first timer. Mind boggling. So now all I've got to do is populate the thing, and that took about an hour. There's just a few components. Suck it all up, and here we go. I have a really neat code practice oscillator. It entertained me for almost a month. And think of the money I saved by not shopping on Amazon and all that time, right? I really made money, I think, by making this thing. And I get it's kind of a childlike pleasure out of this thing, that it's really nice. It was really easy. It was a ton of fun. I learned a ton of stuff, and I'm looking for my next project. Now, I gave a kind of a version of this talk to Martin's Morse group, and Warren asked a really good question about cost. Now, how much did it cost you? And I had kind of intentionally not tried to know that. It's like, how much do your kids cost? Something you just don't want to know. But afterwards, I went and looked at it. And you have a couple of options. You can buy parts, just the parts that you need, from a parts supplier like DigiKey. I like DigiKey. The guy that started it was a ham. They'll sell, there's no minimum quantities. You want 1 resistor, they'll sell it to you. You got to pay shipping. So, you don't want to do that. But if you're in a jam, they'll do it. And as I mentioned earlier, most of the components, you get the CAD models that you need for the KiCad. So instead of spending some time digging through a library trying to find a canned version that I think you'll fit, you can get exactly what you need, and you'll save a bunch of time. If I bought bulk parts, because I thought it would be the cheap way to go. Well, maybe not so much, and it was a lot more trouble. If I had to do over again, I go to DigiKey. Now, if you buy, anybody bought electronic parts from Amazon or one of the China marts, right? You want one of something, and you can get an assortment of 200 of them for not much money. And that's great if you think you're going to use them later. my case, I bought the example here. The 555 timer IC was a whopping 41 cents each on DigiKey. But I could get 50 of them plus the sockets for only $8. So I don't know, did I spend $8 for it? I really only ended up using two, one for the breadboard and one for the one I soldered up. So did I spend 81 cents for two of them on that? Or, you know, if I had to do over again, I'd have bought it from DigiKey. If anybody needs a 555, I got 48 of them. I would love to give away.
Project.
So that's an example of the one part. Now, the total cost, if I had gone to DigiKey, it would have been $39 for the parts, and this is to do two. I wanted to do the breadboard and another set to do the final thing. So call it $50. It's competitive with what the commercial stuff is I showed you later. And I had, like I say, it entertained me for a month. So that was, I think, money well saved. Now, I bought parts, most of them from Amazon. The bad news is I had to spend $103 out of pocket to get it all. But if you allocate if you take how much, you know, 8 of them, if I use kind of the per item price for that, the total, it would have been about $12 in parts plus, so call it 25. But I got all these parts left over, and I'll probably never use them. So like I say, if I had to do over again for a small project, I would go to DigiKey. And that was, I expected it to be the other way around, really. I really thought it would be way cheaper, but in this case, it's not. But like I say, I got parts left over. If anybody's looking for a 555 timer or some of the other little blocks on there, let me know.
Pride you take in your work, incalculable.
Yeah. And you know, it was, yeah, it's like, how do you, what is the value of learning a bunch of neat stuff and being off the streets and out of the bars for over a month? It's substantial.
And
I really did have fun. And maybe you don't want to start from scratch and do the whole start from, you know, the very beginning. But there are a lot of really neat projects online where the author has got the circuit board files out on GitHub or someplace for free. You know, you see that in QST often. It could be a station controller or some key or a memory key or something like that. A Morse tutor. Well, there's a number of those. So all you got to do is go get the PCB files, send them to off to China to get fabbed, buy some parts, and you're on the road. You don't even have to mess with the printed circuit board software if you don't want to. In my case, I had a ball. I think if you see something that you'd like, just do it. There's a ton of help. People in this room will help. A quick Google search will get almost always get multiple YouTubes. Many of them are really, really good. They're written blogs where I said, like I said, I just had to look at the pictures and maybe read the bold type. I didn't even get into the details. And I was able to get through it. I had no exposure to most of this stuff. So if you see something you like and you got half the itch to do the maker thing, I really encourage you to do it. Again, I think Andy will put this up eventually. I started, these are some of here's a link to Dave's presentation, which is excellent. Some of the tutorials that I found really helpful. A quick Google search will probably get you 50 more that are even better. And the rest of this is just, there's some info here on how the timer works and some other stuff that I won't bore you with. But again, my message, go do it. You'll have a good time and learn something. And that's never a bad thing. So that's it. If there's any questions, you can get me now or later. Yeah, Tom.
Very quick question.
Yeah.
Modify, is that an intentional, spelling?
You
I
know,
like it, modifying on the fly.
it is amazing to me. You can look at slides. I found this in my professional career.
Yeah.
I could look slides for days. And as soon as you project it on the screen, the typos flash in big red letters. So
But that was a great typo, I love it. Modify.
I like
thank you for covering that for me. Anything else? Yeah, Rob.
You were talking about the 555, and it is an amazing chip. The other interesting thing is, it's more than 50 years old.
Yeah.
It was early 70s. when it was,
Yeah.
First built. So it's around and.
Yeah, I've
hasn't changed.
seen references to it. I never really messed with it, but yeah, do a Google. So I mean, it's elegant in its simplicity and what it can do for something that is really pretty simple, but it's fascinating. If anybody's, you get bored at lunchtime, look it up. Anything else, or I'll thank you for your time. All right, thank you.